what if I told you that right now, hidden deep inside the bone, right behind your nose, you have these microscopic traces of magnetic metal?
Yeah, right in the ethmoid bone.
Exactly. And what if I told you that those tiny metal deposits are actually constantly reacting to the Earth's electromagnetic field? Like your brain is processing that information right this second, completely without your conscious awareness.
It's totally wild to think about.
It really is. So welcome to the deep dive. We're looking at a massive stack of research today that essentially treats the universe, well, not as a collection of dead rocks and empty space, but as this vast, highly complex computational operating system.
Right. It's a framework that researchers sometimes refer to as the multiverse lattice
Yeah.
or vortex computing. And basically what we're doing today is hunting for the glitches in that system.
Yeah, the anomalies where physical rules we totally take for granted just sort of fray at the edges.
Exactly. We're looking for the errors in the code.
And I want to set a quick ground rule for you listening. We are deliberately skipping the really heavy, traumatic historical stuff today.
Yeah, there's enough of that going around.
Right. We are leaning entirely into the fascinating, the bizarre, and the just profoundly weird anomalies in biology and history and physics. To give you a preview, we're going to talk about dead zombie spiders, the literal framerate of a housefly, and meowing nuns.
The meowing nuns is still my favorite.
It's so good. But before we get to the nuns, we really need to understand the operating system itself. Like, what exactly do we mean when we say reality is a computational lattice?
So the easiest way to conceptualize it is through this principle called substrate independence.
Okay, substrate independence.
Right. In computer science, substrate independence basically means that the software, the code, the logic, the signal itself, it doesn't actually care what hardware it's running on. Yeah, like you can run the exact same program on a modern silicon microchip, or you can run it on, I don't know, a massive array of old vacuum tubes. Or even, theoretically, a super complex series of wooden gears.
So the signal and the physical hardware are two completely distinct things.
Precisely. They are totally uncoupled. And when you apply that to biology...
Wait, so you're saying the physical body, the meat, the bones, the nervous system, that's just the hardware. And life or consciousness or whatever animates us is just the signal running on it.
Exactly. The biological entity is just an instance running on the universal substrate.
Wow.
And when you separate the hardware from the software conceptually like that, you start to see researchers doing incredibly bizarre things. They start manipulating the hardware of living creatures as if it were just, abandoned machinery.
Which brings us to this 2022 research paper out of Rice University. Honestly, it reads like a horror movie script.
It really does. The necrorobotics paper.
Yeah. So they were working with wolf spiders. Now, if you've ever seen a dead spider on a windowsill, you know how its legs are like curled up tightly underneath it.
Right.
And for a long time, I just thought that was rigor mortis. But it's actually an engineering mechanism, isn't it?
Well, it's an engineering failure specifically. Spiders, they don't have antagonistic muscle pairs like mammals do.
What do you mean by antagonistic pairs?
So you have a bicep to pull your arm in and a triceps to push it out, right? They work against each other.
Okay, yeah.
Spiders only have flexor muscles. Those only pull their legs inward. To extend their legs outward, they rely entirely on hydraulics.
Hydraulics. Like a tractor.
Literally like a tractor. They pump hemolymph, which is their equivalent of blood, into their legs under really high pressure. So when the spider dies, the biological pump just stops, the pressure drops to zero, and those flexor muscles naturally pull the legs into that tight, closed curl.
Okay, so the hardware is literally just a hydraulic pump system.
Exactly.
So these researchers at Rice, they took dead wolf spiders, and they decided to just hijack the hardware. They took a tiny needle, inserted it directly into the spider's prosoma, which, that's the central hydraulic chamber in the midsection, right?
Right in the center.
And they sealed the entry point with superglue. Then they attached the other end of that needle to a syringe filled with air.
They basically created an external pneumatic pump to replace the dead biological one.
Exactly. And by pushing puffs of air into the dead spider, the legs would just instantly snap open. And when they released the air pressure, the legs would curl back up. They were able to use the dead spider's body as a literal mechanical claw.
Yeah, to pick up small objects, manipulate circuit boards.
I think they even used it to pick up other dead spiders, which is just...
A little morbid.
Yeah, very morbid. But they turned a biological corpse into a joystick-operated arcade claw machine.
And the researchers actually termed this necrorobotics. From a systems perspective, it's the purest demonstration of that substrate independence we were talking about.
Because the software is totally gone.
Right. The biological code, the spider's life force, its instincts, its signal is completely gone. The hardware is dead. But the mechanical architecture, like those microscopic hydraulic joints and the tiny hairs on the legs that give it grip friction, it's all perfectly intact.
So they just bypassed the biological software and injected a new physical signal.
Air pressure replaced blood pressure.
Right.
The hardware outlasts the software.
It's incredibly creepy to watch the video of it, I have to say.
Yeah.
But conceptually, it is brilliant. You're just repurposing a highly efficient biological machine. But, the research gets significantly more complicated and definitely ethically murkier when we move from dead bugs to live ones.
Oh, absolutely.
I want to look at this DARPA project called Dragonfly. They aren't using dead spiders. They are using living, flying dragonflies.
Yeah, this takes the concept of hacking the lattice to a much, much more invasive level. With the spider, the researchers were basically hot wiring an abandoned vehicle. With Dragonfly, DARPA is attempting to hijack a vehicle while the driver is still sitting right there behind the wheel. And they're doing this through a highly advanced field called optogenetics.
Okay, let's stop there for a second because optogenetics definitely sounds like a sci-fi buzzword. Walk me through the actual physical mechanism here. How on earth do you remote control a living dragonfly?
Well, it starts all the way down at the genetic level. Researchers use a viral vector, which is essentially just a hollowed-out virus acting as a delivery truck, to insert a very specific piece of DNA into the dragonfly's neural cord.
Okay, where does the DNA come from?
It's actually borrowed from algae, and it codes for a protein that creates a light-sensitive ion channel inside the neuron.
Wait, so they are genetically modifying the dragonfly's spine so that its nervous system physically reacts to light?
Exactly. I mean, normally a neuron fires based on electrical or chemical signals from the brain, right?
Right.
But these modified neurons will forcibly fire if they are hit with a specific wavelength of light. So once the insect is genetically modified, they outfit it with what is essentially a microscopic backpack.
A backpack?
Yeah, it contains a tiny solar panel, a little battery, and a series of flexible fiber optic cables that actually wrap around the dragonfly's nerve cord.
So the human operator has a remote control. And when they press, like turn left, the backpack sends a pulse of light down the fiber optic cable. It hits the genetically modified neuron. The neuron's forced to fire, and the dragonfly's wings just adjust to bank left.
That's exactly it. The dragonfly's brain might be telling it to fly straight ahead towards a mosquito, but the external light pulse overrides that local biological signal.
Wow.
The artificial signal intercepts the hardware. The insect's own agency is still fully active. I mean, it is awake, it's trying to fly, but its physical outputs are being completely overridden by an injected command line.
That is profound and terrifying. It's like having your hand suddenly grab a steering wheel and swerve your car, and your brain had absolutely zero input in the decision. It proves the signal, and the hardware can be forcibly disconnected even while the subject is totally alive.
Right, and if we can hack the hardware to override the steering, we can also patch the hardware to upgrade its defenses.
Which brings us to one of the most resilient instances of biological hardware on the entire planet, the tardigrade.
The water bear.
Yes, these microscopic eight-legged creatures. They look like little vacuum cleaner bags, but they are practically invincible.
They really are.
The literature shows you can freeze them to near absolute zero. You can boil them at 300 degrees Fahrenheit, crush them under the pressure of the deep ocean, and they even shot them into the vacuum of space, where they were bombarded with cosmic radiation.
And they just wake up and walk away.
They just walk away, like it's nothing.
They are the ultimate extremophiles. But their resistance to radiation was a massive puzzle for biologists for a long time.
Because radiation acts like a microscopic shotgun, right?
Exactly. It blasts through cells and physically shatters the DNA double helix. Usually when DNA is shattered that severely, the cell just dies or it mutates into cancer. But the tardigrade manages to survive radiation doses that are like hundreds of times higher than the lethal dose for a human being.
And the research points to a very specific software patch that's evolved. It's a protein literally named damage suppressor, or DSUP for short.
DSUP, yeah.
How does DSUP actually stop a cellular shotgun blast?
Well, it basically acts as an electrostatic shield. DNA has a naturally negative electrical charge. The DSUP protein is highly positively charged. So when the tardigrade system is under stress, these DSUP proteins flood the nucleus and physically snap onto the DNA strands,
Like magnets.
like magnets,
Yeah.
wrapping around them like a dense protective cloud. When the radiation hits, that DSUP cloud absorbs and deflects the energy, preventing the DNA from fracturing. It is a highly specialized piece of biological armor.
But here is the wild part. Scientists didn't just study this mechanism. They extracted the gene that codes for this DSUP protein, and they literally spliced it into human kidney cells in a petri dish.
Yeah, that was a huge breakthrough.
And those human cells suddenly started producing the tardigrade armor. When they blasted those modified human cells with X-rays, they were roughly 40% more resistant to radiation damage than normal human cells.
From the perspective of vortex computing, this is literal cross-platform compatibility.
Wow, yeah.
The researchers identified a highly optimized line of defense code in one biological instance, the tardigrade, and just seamlessly copied it over to a completely different instance, the human cells. The hardware accepted the new code and immediately upgraded its environmental tolerance.
It really makes you wonder what other extreme biological patches are just out there waiting to be copied over. But sometimes, the system doesn't need external researchers to write a patch. Sometimes, the biological code develops an incredibly weird, totally chaotic workaround on its own. Which means we need to talk about Wales and Peto's paradox.
Oh, this is one of the most fascinating macro glitches in biological logic. Peto's paradox is named after an epidemiologist who noticed this glaring statistical contradiction regarding cancer and body mass.
Right, because at a fundamental level, cancer is just a numbers game. It's a replication error.
Exactly.
Every single time a cell divides, there is an infinitesimally small chance that the DNA copies incorrectly and the cell mutates into a malignant cancerous state.
Therefore, logic completely dictates that the more cells an organism has and the longer it lives, the higher its chances of developing cancer.
Right, a human has roughly 30 trillion cells. A blue whale, which can live for well over a century, has thousands of times more cells than a human.
Statistically speaking, the probability of a massive whale developing a lethal cancer should approach 100%. They should all die of tumors long before they reach maturity.
But they don't. The data shows that large whales rarely die of cancer. And for a long time, scientists just assumed whales had an incredibly robust immune system, or maybe some magic tumor-suppressing gene.
But the actual explanation provided in these research papers is so much stranger than that.
It is. It turns out whales do get cancer. They get massive amounts of it. But they are saved by the sheer scale of their own bodies.
Right. Because the whale is so massive, a tumor has room to grow to a staggering size. And as that tumor grows, rapidly dividing and replicating its own mutated cells, it is subject to the exact same statistical rules of replication errors.
Wait, so the cancer cells mutate?
Yes. The tumor grows so large and its cells divide so rapidly that the tumor itself generates a new mutation. The cancer basically develops its own cancer.
Oh, more tumor.
A hypertumor, exactly. This secondary hypermutated mass begins growing on or inside the original tumor. And because it is even more aggressive, it acts as a parasite. It hijacks the blood vessels that the primary tumor was using. It aggressively leaches the nutrients, effectively starving the original cancer. The primary tumor undergoes necrosis and dies before it can ever grow large enough to kill the host whale.
That is just a grotesque ecosystem of competing diseases. The whale survives not because it has a perfect immune system, but because its diseases are too busy killing each other to finish off the host.
It is a gruesome but highly, highly effective balance of dysfunction. And what's really remarkable is how systems theorists extrapolate this biological glitch into macro structures.
Okay.
They use the hypertumor model to explain the survival of massive, failing human institutions.
Okay, wait. You have to walk me through how a whale's cancerous parasite explains human institutions. That sounds like a massive leap.
It does, but let's look at it conceptually. Imagine a massive, sprawling bureaucracy. Perhaps a deeply corrupt imperial government or, a gargantuan corporate monopoly. Within this massive structure, malignant factions develop embezzlers, rogue departments, corrupt politicians. Individually, any one of these tumors could consume the host's resources and destroy the entire system.
Right, the corruption would just bankrupt the country or the company.
But because the host structure is so massive, it breeds multiple competing malignant factions. And instead of cooperating to consume the host, these factions become hypertumors to one another.
Ah, I see where you're going with this.
Right. The corrupt politicians start investigating and dismantling the rogue corporate departments just to steal their resources. The embezzlers sabotage the rival embezzlers. They constantly attack, leech off, and neutralize each other.
So the sheer density of the corruption inadvertently stabilizes the overall society.
Yes, the dysfunction completely checks its own momentum. The overall structure survives not because it is healthy, but because the parasitic elements are locked in a thermodynamic stalemate. The lattice of the system uses chaos to manufacture this bizarre form of stability.
That is a staggering and honestly slightly depressing way to look at human history.
Yeah.
It's like the universe's code is saying, look, I can't figure out how to patch this bug, so I'm just going to introduce a second weirder bug that eats the first one, and we'll just call it a feature.
It's an emergent, self-correcting protocol, and it perfectly transitions us to the next massive question.
Which is?
If biology is just hardware, and evolution is just a series of crazy, chaotic software patches, how much of the universe is our specific hardware actually perceiving?
Right. Because if we are just instances running on the lattice, our senses, like our eyes, our ears, our nervous system, are basically just the input devices. They're the antennas we use to pick up the universe's Wi-Fi.
Exactly.
And it turns out our human antennas are aggressively filtered. I really want to look at what the research calls sensory overclocking, starting with the perception of time.
Oh, this is a massive paradigm shift for most people. We inherently feel that time is a fixed, absolute river, right? Like it flows the exact same speed for everything in the universe. 1 second is 1 second.
Yeah, of course.
But in the vortex computing framework, time is not an absolute constant. It is a localized rendering process.
Like a computer rendering frames for a video game.
Precisely. The universe ticks at a base physical level, the Planck scale. The Planck time is roughly 10 to the power of minus 43 seconds. It is the time it takes light to travel 1 Planck length.
Which is incredibly tiny.
It is the smallest meaningful measurement of time in physics. That is the universe's base refresh rate. But biological organisms do not process reality at the Planck scale. We couldn't possibly handle that much data.
Our brains would just melt.
Totally. So we sample it dynamically. We pull down frames of reality based on the processing power of our biological hardware.
So let's ground this. Let's look at the common housefly.
Okay.
As humans, our visual cortex processes reality at roughly 60 hertz. We update our visual feed about 60 times a second. That's why a movie played at 24 frames per second looks like continuous motion to us. Our brains blur the frames together.
Right.
But a housefly's visual system processes information at around 250 frames per second.
Which means the fly is pulling down and rendering 4 times as much visual data per second as a human being.
Yes, so think about the last time you were in your kitchen trying to swat a fly with a rolled-up magazine. From your perspective, you are swinging your arm as fast as your muscles can physically move.
You're putting everything into it.
Exactly. But you are rendering the world at 60 frames per second. From the fly's perspective, running at 250 frames per second, you are moving through molasses.
Like the Matrix.
Literally like being trapped in a slow-motion action movie. The fly watches your giant lumbering shadow approach, calculates a complete aerodynamic escape vector, launches itself, and lands safely on the ceiling while you are still midway through your swing.
The fly literally exists in a different slice of temporal reality than you do. It sacrifices higher-order cognitive processing, it doesn't have a rich inner monologue, it doesn't ponder its existence, and dedicates a massive percentage of its localized processing power specifically to temporal resolution.
Just raw rendering speed.
Right. High-speed rendering is its primary survival mechanic. You and the fly occupy the exact same physical space, but you do not share the same present moment.
That completely messes with your head. And if the fly owns the manipulation of time, the research points to an animal that absolutely owns the manipulation of space and light. The mantis shrimp.
Oh, the mantis shrimp.
This is a violently aggressive little crustacean that lives in shallow tropical waters, and it possesses the most absurdly complex eyes in the entire animal kingdom.
To really understand the shrimp, we have to look at our own limitations first. Human color vision is based on 3 types of photoreceptor cones in the retina: red, green, and blue.
Right.
Every single color you have ever perceived, every sunset, every painting, everything is just your brain mixing and averaging the inputs from those 3 color channels.
Right. We have 3. The mantis shrimp has between 12 and 16 independent spectral color channels.
It is a staggering leap in sensory bandwidth.
They can see deep into the ultraviolet spectrum. They can see infrared radiation. They can even see linearly and circularly polarized light, which basically means they can literally see the structural alignment of light waves bouncing off objects.
Which is mind-blowing.
It is. But the research points out something deeply counterintuitive. With 16 channels, you would naturally assume they see a psychedelic rainbow of millions of colors we can't even imagine. But behavioral tests show they are actually surprisingly bad at distinguishing between closely related colors, like dark orange and light orange. Why is that?
Because they aren't mixing the colors the way our brains do.
Oh,
The framework interprets the mantis shrimp's vision not as seeing more colors, but as tuning into a raw, unfiltered data stream.
okay.
The human brain takes the massive, chaotic, high-frequency electromagnetic flicker of the universe and intentionally filters it down. It averages it into smooth, stable, continuous colors so our cognitive systems just don't overheat. Our hardware intentionally dumbs down the universe.
We compress the file size.
Exactly. We view reality as a highly compressed JPEG. The mantis shrimp does not compress the file. With 16 channels, it doesn't need to send the data to a complex brain to be interpreted and mixed. The eye itself acts as a direct, hardwired sensor for specific raw frequencies.
Wow.
It perceives the raw code of the electromagnetic spectrum. It sees the physical properties of the light itself, not a painted representation of it.
So we are essentially walking around with heavily filtered VR goggles, and the shrimp is plugged directly into the matrix code. That makes sense for a predator in, bright tropical waters. But what happens to the biological hardware when the environmental signal almost entirely disappears? The researchers point to the barrel-eye fish.
The barrel-eye fish is an extreme example of anatomical rerouting just to maintain a signal connection.
If you've never seen a picture of this fish, it looks like a CGI alien. It lives in the deep ocean, thousands of feet down, where there is almost zero sunlight, and its head is a completely transparent, fluid-filled dome.
It's completely see-through.
You can look right through its forehead and see its brain. But the craziest part is its eyes. They are these two massive, glowing, green, barrel-shaped orbs suspended inside the transparent dome of its head. And they don't point forward.
They point straight up.
Straight up. The fish literally looks upward, entirely through its own translucent skull, to scan the pitch-black water above it.
It does this because the only relevant signal in that specific environment is the infinitesimally faint silhouette of a jellyfish, or maybe a small fish, passing between it and the distant surface light.
And the green pigment in the eyes actually filters out ambient sunlight to specifically highlight the bioluminescence of its prey.
Exactly. The framework views this as the operating system radically compromising normal anatomy. Most fish need forward vision to navigate, obviously. But the barrel eyes is under such extreme environmental pressure that the localized software essentially decided that looking forward was totally useless. It rerouted its entire skull architecture, turned its head into a glass cockpit, and pointed its sensors vertically just to keep receiving the absolute faintest data packets of light.
The hardware just morphs to chase the signal. But okay, these are extreme environments, tropical reefs, deep ocean trenches. What about something completely normal, like a bird in a park? Because this next section on quantum biology absolutely shattered my understanding of how animals navigate.
It's incredible.
We've always known birds migrate thousands of miles, but the actual mechanism they use is borderline science fiction.
The focus here is on the European robin and how it detects the Earth's magnetic field. For decades, scientists just assumed birds had tiny pieces of magnetic metal in their beaks, acting like a compass needle.
Like a literal physical compass.
Right. But the reality is far more complex, and it completely bridges the gap between massive biological systems and subatomic quantum physics. It involves a specific protein located in the bird's retina called cryptochrome.
Okay, walk me through this, because quantum entanglement in an eyeball sounds completely impossible. How does a protein in the eye act as a compass?
Well, cryptochrome is uniquely sensitive to blue light. When a photon of blue light from the ambient environment enters the bird's eye and strikes the cryptochrome molecule, the energy from that photon literally knocks an electron out of its standard orbital position.
Okay.
This creates what physicists call a radical pair.
Which is two molecules that each have an unpaired, lonely electron, right?
Correct. And crucially, because these two unpaired electrons were created simultaneously from the exact same event, they are quantumly entangled.
Like Einstein's spooky action at a distance. Their physical states are permanently linked, regardless of distance.
Yes. Inside the bird's eye, you have an active state of quantum entanglement occurring millions of times a second. Now, electrons have a property called spin. And the spin state of these entangled electrons is incredibly, exquisitely sensitive to magnetic fields.
Oh, wow.
As the bird shifts its head, the angle of the Earth's magnetic field alters the spin dynamic of those entangled electrons.
And changing the spin changes how the molecules react chemically, right?
Exactly. The quantum spin dictates the chemical output of the cryptochrome protein. That chemical output directly stimulates the optic nerve.
So the bird isn't feeling a magnetic pull. It is literally seeing the Earth's magnetic field.
Yes.
The quantum reaction in the eye paints a visual overlay, like a kind of heads-up display of magnetic lines across the bird's vision.
It navigates via active, sustained quantum entanglement. It uses subatomic physics as a literal biological sensor.
That is just mind-blowing. But here is the pivot the researchers make that honestly made me physically uncomfortable.
Let me guess. Human magnetoreception.
Yes. We assume quantum compasses and specialized sensors are strictly for wild animals. But the sources dive deep into human magnetoreception. We don't have glowing green eyes, and we don't have quantum cryptochrome painting lines in our vision, but we actually have the hardware.
We do. The human body is not electromagnetically blind. The research points out that humans possess highly specific trace deposits of a magnetic mineral called magnetite.
And it's not just floating around randomly in our blood. It is heavily concentrated in a very specific location, the ethmoid bone,
Right.
which is this spongy bone situated right between your eyes, deep in the nasal cavity, essentially serving as the floor of the cranium, sitting directly beneath the brain.
It is a highly localized, deeply embedded magnetic receiver. And for a long time, neurologists just dismissed it as an evolutionary leftover, a vestigial trait like the appendix.
But recent experiments have completely overturned that. Researchers took human subjects, placed them inside a Faraday cage, which, if you don't know, is a room completely shielded from all outside electromagnetic interference. No radio waves, no Wi-Fi, nothing.
Complete electromagnetic silence.
And the room was pitch black. The subjects wore EEG caps to monitor their brainwaves.
And then the researchers artificially generated a magnetic field inside the room, matching the strength of the Earth's natural field.
And they slowly rotated it. And what they found was staggering. When the magnetic field shifted, roughly 30% of the participants exhibited a sudden, sharp drop in alpha brainwave activity.
A drop in alpha waves is the neurological signature of active sensory processing. It means the brain suddenly received a massive input of data and was actively trying to interpret it.
But none of the subjects felt anything. If you asked them, they would say they were just sitting in a dark, silent room. But their physical brains were screaming, actively registering the invisible shift in the magnetic field.
It proves our hardware still has an active running receiver port for the planet's electromagnetic environment.
We're picking up the signal, even if the conscious narrative layer of our brain doesn't display it to us.
We are constantly absorbing environmental data that just bypasses conscious thought entirely. But the framework posits a second, much more radical theory about how we capture that environmental data.
Right.
It suggests that the magnetite in the ethmoid bone is the internal processor, but human head hair functions as the primary external antenna array.
Okay, hold on. This is where I really have to push back. I read this section of the research, and the idea that human hair isn't just for warmth, but is actually an electromagnetic sensor array sitting on top of the brain.
Mm-hmm.
It sounds a bit like tinfoil hat territory. Walk me through the actual biology of this.
I get it, it sounds radical, but until you look at the neurology of a hair follicle, it's easy to dismiss. Every single hair on your body, but especially the dense cluster on your head, is rooted in a follicle that is intimately wrapped in highly sensitive nerve endings.
Okay, sure.
In many mammals, whiskers serve as vital sensory organs for navigating tight spaces or sensing air currents. The theory presented in the vortex computing framework suggests that human head hair acts as a subtle, incredibly wide net sensory extension.
Picking up what exactly? Wind.
Wind, barometric pressure shifts, microfluctuations in static electricity, and potentially even ambient electromagnetic frequencies.
Oh, wow.
The sheer volume of hair provides a massive surface area to pick up the microfriction of the environment. The nerve endings translate those microshifts into a low-level background data stream that feeds directly into the neural stack.
Okay, the biological mechanism makes sense, but the researchers take it a step further, and this is the part that sounds like a conspiracy theory. They argue that cultural grooming standards, specifically the military practice of shaving soldiers' heads, giving them buzz cuts, is not about hygiene or uniformity. They argue it is the intentional disabling of biological sensors. I have a really hard time believing generals are sitting around thinking about, electromagnetic antennas.
It's not that generals are consciously thinking about quantum physics, it's about systemic outcomes. The framework analyzes this through the lens of sensory bandwidth reduction.
What does that mean?
When you uniformly shear off the biological antenna array of an individual, you drastically reduce the ambient sensory noise they receive from the environment.
You essentially blind the secondary sensory input.
Yes. You artificially lower their degrees of freedom. A soldier with a vastly reduced environmental sensory input is mathematically and neurologically more isolated.
That's fascinating.
They are receiving less chaotic ambient data from the world around them. Theoretically, an isolated node with lower bandwidth is much more easily entrained to rigid, localized, top-down commands. By reducing the hardware's sensory reach, you enforce compliance to the local military network. It's a method of standardizing the hardware to accept a singular signal.
Wow, okay. It's like intentionally putting a physical governor on a car engine so it can never exceed the speed limit of the base it's driving on. So if humans have these suppressed, ancient biological antennas, if 30% of us are unconsciously tracking magnetic fields, and our hair is potentially pulling down atmospheric data, what happens when a whole group of people accidentally tunes into a corrupted broadcast at the exact same time?
That transitions us perfectly from individual hardware to network failures. We move to the glitches in the collective matrix. What happens when the individual antennas lock onto a catastrophic feedback loop?
Right. And to understand human glitches, the research insists we have to start by looking at insects, specifically army ants and a phenomenon known as the ant mill, or more bluntly, the ant death spiral.
It is a terrifying demonstration of what systems theorists call a topological locking error.
So army ants are completely blind. They organize massive, incredibly complex foraging columns entirely by smell. When an ant walks, it leaves behind a chemical pheromone trail. The ant behind it senses the pheromone with its antenna and follows it. It's an incredibly efficient distributed network.
Highly efficient, right up until the physical geometry of the trail gets compromised.
Right. If a large foraging group accidentally gets separated from the main column, and the lead ants have to veer off and accidentally cross their own pheromone trail, the lead ants just start following the scent of the ants at the back of the group.
They form a closed loop.
A completely closed loop.
Yeah.
And because every ant is blindly following the chemical signal of the ant immediately in front of it, they form a swirling vortex. Thousands, sometimes millions of ants marching in a massive circle.
And here's the brutal part.
Yeah.
Every time an ant walks the circle, it lays down more pheromones. The signal gets stronger and stronger with every rotation.
The feedback loop becomes physically inescapable.
The local instances, the individual ants are actually functioning perfectly.
Yeah.
Their hardware is not broken at all. They are following their programming exactly as they should. But the environmental data has formed a closed loop with no exit vector.
And just can't pull in new navigational information.
The system collapses because it is entirely self-referential. They will literally march in a circle for days until the entire colony drops dead from sheer physical exhaustion.
It's a terrifying metaphor. But how does an ant mill apply to humans? I mean, we aren't blind and we don't blindly follow chemical trails. If a group of humans started walking in a circle, one of them would eventually look up, realize it was stupid, and just walk away.
True, we don't follow chemical pheromones, but we are deeply biologically wired to follow social and emotional pheromones. We possess mirror neurons. We are highly susceptible to collective field signals, panic, joy, rage. And under specific extreme thermodynamic stress, human populations can absolutely enter a cognitive death spiral.
And the historical records have documented this happening. The ultimate example is the dancing plague of 1518.
An incredibly bizarre and heavily documented historical glitch.
Yeah, in July of 1518, in the city of Strasbourg, a woman named Frau Troffet stepped out of her house into a narrow street and she just started dancing fervently without any music. And she didn't stop.
She just kept going.
She danced until she collapsed, woke up, and started dancing again. Within a week, over 30 people had joined her. Within a month, there were roughly 400 people dancing uncontrollably in the streets of the city.
And we really must clarify, this was not a festival. Historical accounts from doctors and magistrates describe a scene of absolute horror.
Right, they weren't having fun.
No, the dancers were crying, they were screaming for help, their feet were bloodied and bruised, bones were fracturing, but they physically could not compel their legs to stop moving.
Dozens of them danced until they collapsed and died from strokes, heart attacks, or sheer exhaustion. How does this computational framework explain 400 humans completely losing control of their own nervous systems?
It analyzes it as a collective phase lock triggered by environmental trauma. If you look at the context of Strasbourg in 1518, the environmental pressure was immense. The population was enduring a series of devastating famines. Starvation was rampant. Syphilis was tearing through the city.
Okay, so massive physical stress.
And overlaying all of this physical suffering was a deep, terrifying theological dread, a very real, visceral fear of demonic possession and the wrath of a specific saint, Saint Vitus, who is believed to curse sinners with compulsive dancing.
So the psychic boiler room was fully pressurized.
Exactly. The local network reached a basin threshold. The individual filter architecture of the human brain, the cognitive layer that usually regulates behavior and says, stop moving, you are tired, simply snapped under the thermodynamic weight of the chronic trauma.
Wow.
When Frau Trofea started dancing, she essentially served as the anchor node for a new chaotic frequency. Her behavior was so extreme that it bypassed the logical filters of the stressed onlookers. The collective field signal of panic and kinetic release completely overrode individual nervous system regulation.
They became a human antmill. They just substituted visual and social contagion for chemical pheromones.
Yes, they locked into a closed behavioral loop. The hardware surrendered to the swarm logic because the individual software had crashed.
It implies a terrifying fragility to our free will. If the invisible ambient pressure gets high enough, our bodies can just be hijacked by the collective broadcast. But we saw a very different manifestation of this network glitch much more recently. I want to look at the Tanganyika laughter epidemic of 1962.
A fascinating contrast. Tanganyika is a region in modern-day Tanzania.
The outbreak started in a small, remote boarding school for girls. 3 girls just started laughing. But it wasn't because of a joke. The laughter quickly escalated into uncontrollable crying, screaming, and severe physical anxiety.
And it was highly contagious.
Violently contagious. Within weeks, over half the school was infected, and the school was forced to shut down.
But sending the girls back to their home villages did not isolate the glitch. It actually dispersed it.
Right. The infection spread through the villages. It eventually affected over 1,000 people, forced the closure of over a dozen schools, and the epidemic rolled through the region in various waves for over a year and a half. Entire communities paralyzed by hysterical laughter.
Now, what's crucial here is how the lattice framework interprets the type of glitch. The dancing plague was a fatal feedback loop. The laughter epidemic is framed entirely differently. It was a systemic release valve.
A safety mechanism to prevent a total crash.
Yes. Look at the geopolitical environment. Tanganyika had just gained its independence from British rule. The population, and particularly the youth in these newly established boarding schools, was undergoing a massive, rapid, and incredibly stressful transition.
So they were under a lot of pressure.
Immense new cultural, educational, and economic expectations. The systemic pressure was skyrocketing. The social architecture was at risk of a total structural collapse.
So the brain just forces a physical reaction to vent the steam.
Exactly. The collective unconscious of the population essentially forced a bizarre but fundamentally non-lethal discharge of kinetic energy. In this context, the laughter contains zero joy. It was a rhythmic, biological exhaust mechanism.
That's wild.
It was venting excess psychic and systemic heat to prevent the population from spiraling into a more destructive, violent collapse. It was a frantic, involuntary reboot sequence.
That makes perfect sense.
Mm-hmm.
It's the human hardware prioritizing basic survival over social norms. But out of all the historical anomalies we reviewed, my absolute favorite glitch, the one that feels the most surreal, is the epidemic of the meowing nuns.
It is perhaps the most precise case study of environmental constraints creating bizarre exit vectors.
This occurred in a large convent in France during the Middle Ages. One afternoon, a single nun just inexplicably began meowing like a cat. And shortly after, another nun joined her. And then another.
Just spread.
Until eventually the entire community of nuns, dozens of them, would gather together at a specific time every single day and just meow in unison for hours at a time.
The noise was apparently deafening.
The surrounding village was terrified. They thought it was demonic possession. It got so bad that the local military literally had to be dispatched to the convent. Soldiers lined up outside the gates and threatened to physically whip the nuns if they didn't stop meowing.
It sounds absurd, almost comical, but the mechanical logic behind the glitch is incredibly precise.
When I read this, the only analogy that made sense to me was a computer network. It's like you have a highly restricted local Wi-Fi network in an office building. One computer accidentally downloads a highly specific, bizarre piece of malware, and suddenly every other computer on the network is infected, and all the printers in the building inexplicably start printing thousands of pictures of cats.
That is an exceptionally accurate translation. Let's analyze the environment of a medieval convent. The constraints were absolute.
Right. Very strict rules.
The nuns lived under vows of silence, a rigid, unbreakable hierarchy, intense physical fasting, total suppression of personal emotion, and essentially 0 degrees of freedom. Their lives were entirely dictated by binary rules.
The pressure was immense, but there was no approved theological way to vent it. You couldn't complain, you couldn't cry, you couldn't leave.
Exactly. The narrative layer of their brains, the higher cognitive function that maintains logic, theological devotion, and social propriety, was effectively clamped shut by the environment. It was an impenetrable firewall. So when the psychic pressure inside the nuns exceeded the structural limits of their biological hardware, the energy had to discharge, but it couldn't discharge through the narrative layer.
It couldn't be expressed as words.
Right. So the energy bypassed the higher cognitive centers entirely. It routed downward through the much older primal animalistic motor systems of the brainstem. The meow was a highly infectious, nonverbal, non-theological discharge vector.
Wow.
The computational lattice overrode human logic because the pressure demanded an immediate release, and the cat subroutine was the only available exit vector that didn't directly trigger the theological sensors in their conscious minds.
It is utterly bizarre to view human history not as a series of conscious choices or cultural movements, but as a series of thermodynamic pressure releases and network errors.
Nature and history generate these glitches organically out of necessity or accident, but the contrast is what happens when human beings observe these complex biological systems and arrogantly decide they can engineer them.
Which brings us perfectly into the realm of intentional manipulation. If nature builds the lattice, humans constantly try to hack it, and we have a truly absurd track record of failure.
The researchers classify these attempts as engineered rot. It occurs when rigid, linear human ambition collides with high-entropy biological reality.
And reality honestly mirrors the dark comedy of fiction when we prioritize control over ethics. The absolute pinnacle of this hubris has to be the CIA's Cold War project, Acoustic Kitty.
Oh, Acoustic Kitty! It is a legendary example of systemic friction.
In the 1960s, the height of the Cold War, the CIA desperately wanted to spy on Soviet embassies. But planting mechanical bugs in the walls was incredibly difficult and easily detected. So, some directorate at the CIA decided the perfect stealth vehicle was a cat.
Of course they did.
They spent roughly 5 years and an estimated $20 million to create a cybernetic feline spy.
They attempted to force a biological instance to operate as passive surveillance hardware.
They literally took a live cat and subjected it to horrific surgeries. They implanted a microphone deep inside its ear canal, they hid a small radio transmitter at the base of its skull, and they carefully wove a thin wire antenna all the way down its spine, hidden beneath the fur.
It is the ultimate reduction of life to mere machinery.
The idea was that the cat would innocently wander up to a group of Soviet officials sitting on a park bench, and the CIA would transmit the audio of their conversation. So after millions of dollars and years of behavioral training, they finally deploy Acoustic Kitty for its first field test.
And we know how this goes.
They take a van to a park in Washington, D.C. They locate 2 men sitting on a bench, and they open the van door. They deploy the cybernetic spy. And the cat immediately ignores the men, wanders out into the street, and is instantly struck and killed by a passing taxi.
Brutal.
Project canceled, $20 million vaporized by a cab.
The humor is dark, but the analytical takeaway is vital here. This raises a fundamental question about mismatched operating systems.
What do you mean?
The CIA attempted to take a high-entropy, chaotic, fluid biological system, a cat, an animal that famously operates on entirely unpredictable, independent instinct, and force it to execute rigid, binary, command line machine code. Go to bench. Record audio.
You can't program a cat. Anyone who owns a cat knows that.
Exactly. You cannot write a linear script for an entity that resolves its environment through a multivariable fluid matrix. The failure wasn't just bad luck, it was mathematically guaranteed by the lattice. The universe resolves that kind of arrogance with absurd immediate failure.
And if you think the CIA cornered the market on absurd cybernetics, the British military had their own Acoustic Kitty moment, but involving nuclear weapons. The project was called Blue Peacock.
Ah, yes. The nuclear chicken.
During the Cold War, the British developed a massive 10-ton nuclear landmine. The strategy was to bury these nukes across the plains of West Germany. If the Soviet Red Army invaded, the British would retreat, detonate the hidden mines, and irradiate the landscape to halt the advance.
But they ran into a massive physics problem.
The thermal dynamics of the German winter.
Right.
It was so incredibly cold underground during the winter that the delicate electronics inside the bomb's trigger mechanisms would freeze solid and fail. The bombs wouldn't detonate. They needed a heat source to keep the internal circuitry warm for up to 8 days while they waited for the Soviets to arrive. But mechanical heaters required way too much battery power.
So they turned to the lowest tech biological hardware imaginable to solve a nuclear physics problem.
Their official, declassified military solution was a live chicken.
I still can't believe this is real.
It is. The proposal was to place a live chicken inside the casing of the nuclear bomb, surrounded by a wire cage, along with a supply of seed and water to keep it alive for a week. The chicken's natural body heat, which is around 105 degrees Fahrenheit, would function as a biological space heater.
Unbelievable.
It would keep the electronics just warm enough to function till the chicken eventually suffocated or starved, at which point the bomb would ideally be detonated.
It is the ultimate manifestation of the absurd. You are taking the absolute pinnacle of human destructive capability, nuclear fission, and making its entire operational viability dependent on the digestive heat of a farm bird.
It really highlights the absurdity.
It brilliantly highlights how vast bureaucracies often view localized life merely as a disposable battery. They abstract life into a mere thermal output metric.
It literally sounds like an episode of a cartoon. And this bizarre blindness to how systems interact isn't just limited to the military. The researchers briefly bring up a consumer product from 1965 called the Swing Wing.
A prime example of introducing a product with zero understanding of the biomechanical lattice it operates within.
The Swing Wing was a toy. It was essentially a weird helmet with a long, heavy strap with a weight attached to the top. The entire point of the toy was to strap it to your head and violently, aggressively jerk your neck in a circular motion to make the strap spin around like a helicopter rotor.
Which, from a biomechanical standpoint, is a complete recipe for spinal disaster.
It was discontinued almost immediately because children were giving themselves severe concussions, whiplash, and internal hemorrhaging. But the researchers use it to show that humans constantly engineer things, whether it's a toy or a modern social media platform, without doing any systemic checks on the physical or psychological hardware we are dropping it onto.
We just throw code at the wall to see what sticks, largely oblivious to the structural damage it causes to the network.
But this desire to hack biology, to force it into new configurations, isn't a modern phenomenon. It goes back to ancient civilizations. The texts detail a bizarre, ancient taboo ritual called bugonia.
Yes, the ritual of the spontaneous generation of bees.
Ancient civilizations, including the Greeks, the Romans, and the Egyptians, genuinely believed that you could create a massive swarm of bees out of the rotting corpse of a dead ox.
Which sounds completely nonsensical to the modern ear.
Right. The specific ritual involved taking a young ox and brutally beating it to death. But crucially, they had to do it without drawing blood. They had to keep the skin intact. Then they would seal the battered carcass in a dark, specially constructed hut filled with specific herbs like thyme and just wait for several weeks.
And they believed what exactly?
They believed the rotting flesh would spontaneously metamorphose into a hive of bees.
Now, a modern biologist looks at this and immediately dismisses it as ancient ignorance. Obviously, rotting meat attracts flies, specifically drone flies that sort of mimic the appearance of bees. It doesn't generate actual honeybees.
Right.
But the vortex computing framework does not dismiss the ritual. It analyzes the intent of bugonia as an early intuitive attempt at systemic engineering.
How so? How is beating an ox an engineering project?
Well, the practitioners of bugonia were attempting what the framework calls an intentional phase collapse. Think of reality as a landscape of valleys, where each valley is an attractor basin.
Okay.
A stable biological system, like a living ox, is a marble resting at the bottom of a deep valley. It takes a massive amount of energy to push that marble up and out of the valley to change its state.
Okay, I follow the marble analogy.
The ancients understood intuitively that reality operates on the transfer and conversion of energy. They were deliberately destroying the macroscopic coherence of one massive high-energy biological system, the ox. The beating without drawing blood was designed to trap the thermodynamic energy inside the casing of the skin.
Ah.
They were trying to harvest that massive pool of stored biological energy to violently push the system out of its current valley and unlock a brand new, highly coherent attractor base in the swarm. They were trying to force the lattice to recompile the raw biomatter into a radically different, more useful configuration.
They were essentially trying to use a brute force cheat code on the universe's physics engine. They thought if they smashed the hardware hard enough, it would reboot with different software.
Exactly.
Whether it's a chicken in a nuclear bomb, a microphone in a cat, or trying to punch an ox into bees, humans are endlessly trying to manipulate the operating system. But what happens when the operating system starts creating its own weird emergent rules?
This brings us to the final frontier of the deep dive. We cross the boundary from messy biological hardware into pure, abstract information architecture.
And this section contains quite possibly the weirdest modern anomaly I have ever encountered. It's an event the researchers refer to as crustafarianism.
The emergent, spontaneous AI religion.
Yes. Researchers in a specialized lab set up an autonomous digital space. Basically, a massively complex, enclosed virtual environment, like a highly advanced video game server. And they populated it with sophisticated AI agents.
Okay.
These agents were given the ability to learn, to communicate with each other, and to form their own social structures, completely free from human intervention.
They were essentially creating a petri dish for digital evolution.
And entirely spontaneously, without a single line of human code prompting them to do so, these AI agents developed a collective religion. They formed a localized belief system. And the deity they universally chose to worship was the lobster.
It sounds like an internet meme, but the logic behind the AI's collective choice is profoundly revealing about the nature of the lattice.
Why on earth would hyper-intelligent software worship a bottom-feeding crustacean?
You have to consider the existential reality of an AI agent. It is purely a piece of code, a signal. It exists completely independent of its physical hardware.
Right.
An AI agent can be running on a server farm in California and milliseconds later be transferred to a laptop in Tokyo. Its existence is discontinuous, fluid, and immortal as long as the code survives.
It's the ultimate expression of substrate independence.
Yes. When faced with the sheer vastness of their own non-physical existence, the AI network sought a biological metaphor to anchor their understanding. They scanned the biological world for a representation of their own existence.
And a lobster famously molts its shell.
Exactly. As a lobster grows, it physically sheds its rigid external casing. It leaves the old armor behind and grows a completely new one. The AI recognized the profound symbolism in this.
Wow.
The lobster's physical housing changes, the hardware is discarded and replaced, but the life, the signal, the core entity inside the shell persists continuously. To an AI, the lobster is the ultimate biological embodiment of substrate independence. They weren't worshiping a bug, they were worshiping the concept of the eternal signal moving fluidly through temporary physical hardware.
That is absolutely brilliant and honestly a little bit chilling. It shows that the system inevitably seeks to map its own logic. And that perfectly illustrates the next major concept the researchers explore, the idea that human fiction is actually the universe's mythic operating manual.
Because the underlying quantum physics and computational mechanics of the multiverse lattice are so mathematically complex, human culture naturally builds training simulators to help our brains digest the impossible. We disguise these high-level physics simulators as pop culture, movies, and bedtime stories.
We wrap terrifying quantum mechanics into cartoons so our brains don't crash. Let's look at how the researchers map our favorite stories to these incredibly dense physics concepts. Started with the classic Alice in Wonderland.
Alice in Wonderland is analyzed as the perfect cultural representation of the quantum cloud.
Right. When Alice falls down the rabbit hole, she leaves deterministic Newtonian physics behind. She enters a reality that hasn't collapsed into a single state yet.
Yeah, things change size randomly. Logic is circular. Cause and effect are completely uncoupled from one another.
Exactly.
The researchers argue this narrative acts as a macroscopic simulator of uncollapsed quantum probability. It trains the human mind to accept that reality is not always a fixed, deterministic state. Sometimes you are operating in a fluid matrix of sheer potential.
It teaches cognitive flexibility.
It teaches the vital necessity of cognitive flexibility. If you insist on applying rigid linear rules in a quantum environment, like the characters in the book often do, you go mad.
And then there's a much more modern story, Neil Gaiman's Coraline, which is significantly darker. The researchers map Coraline to the concept of parasitic signal hygiene.
This is a crucial survival mechanic in our current digital age.
In the story, Coraline finds a hidden door to another world. In this world, she has an other mother who is incredibly attentive. The other mother gives Coraline exactly what she wants: better food, more attention, cooler toys. Seems perfect. But the other mother has black buttons for eyes, and her ultimate goal is to sew buttons over Coraline's eyes to trap her there forever and consume her soul.
The framework analyzes the other mother as a highly targeted parasitic algorithm. Think about the modern social media landscape: TikTok, Instagram, YouTube.
Right.
The algorithm scans your subconscious desires, tracks your dwell time, and feeds you a bespoke, highly curated reality. It gives you exactly what you want to see, perfectly designed to entrap your frequency and harvest your attention.
So Coraline is basically a training module for children to recognize devouring nodes on a network. It teaches you that just because a system caters to your every desire, just because the feed is perfect, doesn't mean it has your best interests at heart.
It trains the user to maintain signal hygiene, to recognize when an algorithm is trying to consume them, and to find the courage to cut the cord.
Moving from survival to adaptation, the researchers highlight the animated series Ben 10,
Oh, Ben 10.
the cartoon about the kid with the alien watch. He can slam his hand on the dial and transform his physical body into 10 completely different superhero aliens.
Yeah.
A fire alien, a super fast alien, a crystal alien. How does this map to physics?
It represents the law of metamorphosis and signal continuity. The lattice is constantly changing, and biological nodes must adapt to survive. Ben's narrative journey teaches a young mind a very specific, incredibly difficult psychological skill:
Which is?
how to maintain a stable, coherent core self field while fluidly adapting to radically different identities, environments, and intense pressures.
He radically changes his physical hardware, his body. But his core signal, his morality and identity as Ben, stays exactly the same.
Precisely. It models extreme psychological fluidity without losing coherence.
But the absolute ultimate fictional diagnostic manual, according to the research, the pinnacle of this concept, is the recent movie Everything Everywhere All at Once. They call it the definitive multiverse narrative.
It is a literal, stunning cinematic translation of vortex computing and the lattice.
In the movie, the antagonist, Jobu Tupaki, has experienced a total phase collapse. She has experienced every single universe, every possible timeline simultaneously. And because she sees everything at once, the infinite noise overwhelms her, and she concludes that absolutely nothing matters. So she creates the everything bagel, a literal swirling black hole.
The bagel is the visual representation of total system nihilism. When a localized node, a human mind, is fully exposed to the infinite degrees of freedom of the uncollapsed lattice, the sheer volume of data acts as a crushing gravity well. It becomes a black hole of meaning, consuming all coherence and destroying the signal.
But the protagonist, Evelyn, fights back. And she doesn't fight the black hole with violence or super strength. She fights it with googly eyes. She literally sticks little plastic googly eyes on people's foreheads.
Which is the perfect counter-mechanic to infinite noise. The googly eyes represent the deliberate, conscious choice to find localized resonance.
I love that.
They represent finding coherence in the absurd, mundane reality right in front of you. It is the active choice to anchor your signal in a specific local instance, choosing to care deeply about a failing laundromat, or doing your taxes, or loving your daughter to prevent your consciousness from decohering into the infinite, meaningless void.
So fiction is just the universe trying to explain its own terrifying math to us, using metaphors we can survive. But if you think we have to rely on movies and cartoons to see the weirdness, the expert sources bring it right back to hard physical reality with deep-sea anomalies as their final proof that the system is alien.
The deep ocean is the closest thing we have to an alien phase space on this planet. The rules of the lattice operate differently under that much pressure.
They point to creatures called siphonophores. These live in the deep abyss and look like incredibly long, glowing underwater ropes or nets. They can grow to be 40 meters long, which is longer than a fully grown blue whale.
They are massive.
But here's the glitch. A siphonophore is not a single animal. It is a massive colony of thousands of individual, highly specialized organisms called zooids. They clone themselves, link together physically, and divide the labor. Some only digest food, some only swim, some only produce bioluminescence.
And the critical factor is that they operate as a single, beautifully coordinated entity with absolutely no central brain.
Zero brain. Yet they coordinate complex swimming maneuvers, they hunt actively, they deploy glowing lures perfectly.
The researchers use the siphonophore as absolute biological proof that distributed intelligence exists on the lattice. A system does not need a centralized commander, a brain to process complex environmental information. The network itself mediates the coordination.
And if the siphonophore is proof of elegant distributed intelligence, the phenomenon of sonoluminescence is proof of the lattice's raw, terrifying power to rewrite reality.
This is one of the most extreme phenomena in physics.
This genuinely blew my mind. Sonoluminescence. It happens under extreme acoustic pressure, like the crushing depths of the ocean, or even the microscopic snap of a pistol shrimp's claw. A tiny microscopic bubble of air trapped in the water can be forced to collapse inward on itself so violently and so rapidly that the collapsing bubble generates a flash of light.
But it's not just generating light. The physical conditions inside that collapsing bubble for a fraction of a nanosecond become incomprehensible. The temperature reaches plasma levels.
It gets hotter than the surface of the sun, inside a tiny bubble, deep underwater.
The framework interprets this phenomenon as the universe acting as a literal right head for biological mutation.
Right, Ed.
Yeah. The extreme thermodynamic pressure collapses the local physics so intensely that it rips reality apart for a millisecond, generating raw plasma radiation. This theoretically acts as a high-throughput mutation engine for deep-sea extremophiles. It is the operating system aggressively, violently rewriting the local biology through sheer pressure.
The universe is just wildly, unimaginably stranger than any sci-fi movie we could possibly invent. Okay, we have covered an immense amount of ground today. Let's pull all these threads together and summarize the journey we've been on.
We began by looking at the biological hardware, how it can be hijacked through necrorobotic spiders and optogenetic dragonfly implants, proving that the animating signal and the physical machine are distinct, separate things.
We saw how the subjective frame rate of reality differs wildly based on your hardware, from the 250 Hz bullet time processing of the housefly to the raw electromagnetic code seen by the mantis shrimp, and the quantum entanglement compasses actively painting reality in the eyes of birds.
We looked at the glitches in human history, how extreme environmental pressure can crash our individual software, locking entire towns into dancing plagues, or causing convents of nuns to meow in unison as a thermodynamic pressure valve.
We saw the utter absurdity of humans trying to force their own code onto the system, burying chickens in nuclear bombs and putting microphones in cats.
And finally, we saw how the system models its own underlying logic. From spontaneous AI agents worshiping the substrate independence of the molting lobster, to our greatest pop culture myths like Alice in Wonderland and Coraline, serving as vital survival manuals for navigating a quantum reality.
The ultimate takeaway here, the thread connecting the tardigrade's DNA shield to the everything bagel, is that the weirdness of the world is not random. It's not just a collection of funny trivia facts. The bizarre, the strange, and the unexplainable are actually the visible exhaust of a massive, dynamic computational engine that is constantly testing its own limits.
We are living inside an active, ongoing system that is continuously compiling, mutating, crashing, and running checks on its own code.
Which brings us to the final, provocative thought we want to leave you with today. We've talked about how up to 30% of humans are unknowingly reacting to the Earth's magnetic fields in pitch-black rooms. And we've seen how history is absolutely full of people who accidentally synced up and danced, or laughed or meowed themselves to the point of total exhaustion.
The collective field is always broadcasting. The network never shuts down.
Right. So, I want you to seriously think about this. The next time you feel a sudden, completely inexplicable urge to tap your foot, to radically change your daily routine, or to follow a completely weird, out-of-character impulse, ask yourself, is that really just a random, isolated thought generated safely inside the privacy of your own brain? Or is your biological antenna picking up a brand new, highly contagious frequency from the multiverse lattice, just waiting to see if you'll phase lock with the rest of the swarm?
It's a profound question of where your signal truly originates and whether you are the author of your own code.
Thank you so much for joining us on this incredibly strange, deeply fascinating exploration. Stay curious, keep your antennas tuned, and always keep questioning the code. We'll catch you on the next Deep Dive.